that world where if you have this like Jarvis-like thing that can reason, what do you think it does to products that you use today where the interface is very valuable? So for example, if you look at an Instacart or if you look at an Uber or if you look at a DoorDash, these are not services that are meant to be pipes that are just providing a set of APIs to a smart set of agents that ubiquitously work on behalf of 8 billion people. What do you think has to change in how we think about how apps need to work, of how this entire infrastructure of experiences need to work in a world where you're agentically interfacing to the world? You know?
I'm actually very interested in designing a world that is equally usable by humans and by AIs. So I like the interpretability of that. I like the smoothness of the handoffs. I like the ability that we can provide feedback or whatever. So, DoorDash could just expose some API to my future AI assistant and they could go put the order in or whatever. Or I could say I could be holding my phone and I could say, okay, AI assistant, you put in this order on DoorDash, please. And I could watch the app open and see the thing clicking around and I could say, hey, no, not this. Or there's something about designing a world that is usable equally well by humans and AIs that I think is an interesting concept.
And
same reason I'm more excited about humanoid robots than sort of robots of very other shapes. The world is very much designed for humans. And I think we should absolutely keep it that way. Mm-hmm. And a shared interface is nice.
So you see voice, chat, that modality kind of gets rid of apps. You just ask it for sushi. It knows sushi you liked before. It knows what you don't like and does its best shot at doing it.
It's hard for me to imagine that we just go to a world totally where you say hey, ChatGPT, order me sushi. And it says, okay, do you want it from this restaurant? What kind, what time, whatever. I think visual user interfaces are super good for a lot of things. And it's hard for me to imagine a world where you never look at a screen and just use voice mode only. But I can't imagine that for a lot of things.
Yeah, I mean, Apple tried with Siri. Supposedly you can order an Uber automatically with Siri. I don't think anybody's ever done it because why would you take the risk of not putting it in your phone?
To your point, the quality is not good, but when the quality is good enough, you'll actually prefer it just because it's just lighter weight. You don't have to take your phone out. You don't have to search for your app and press it. And it automatically logged you out. Oh, hold on, log back in. Oh, TFA. It's a whole pain in the ass.
It's like setting a timer with Siri. I do every time because it works really well and it's great and I don't need more information. Exactly. But ordering an Uber, I want to see the prices for a few different options. I want to see how far away it is. I want to see maybe even where they are on the map because I might walk somewhere. I get a lot more information I think in less time by looking at that order the Uber screen than I would if I had to do that all through the audio channel.
I like your idea of watching it happen. That's kind of cool.
I think there will just be different. There are different interfaces we use for different tasks, and I think that'll keep going.
Of all the developers that are building apps and experiences on OpenAI, are there a few that stand out for you where you're like, okay, this is directionally going in a super interesting area, even if it's like a toy app? But are there things that you guys point to and say, this is really important?
I met with a new company this morning, or barely even a company. It's two people that are going to work on a summer project, trying to actually finally make the AI tutor. And I've always been interested in this space. A lot of people have done great stuff on our platform, but if someone can deliver the way that you actually they used a phrase I love, which is this is going to be a Montessori level reinvention for how people learn things.
Yeah.
But if you can find this new way to let people explore and learn in new ways on their own, I'm personally super excited about that. A lot of the coding related stuff you mentioned, Devin, earlier, I think that's a super cool vision of the future. The thing that healthcare, I believe should be pretty transformed by this. But the thing I'm personally most excited about is the sort of doing faster and better scientific discovery. GPT-4 clearly not there in a big way, although maybe it accelerates things a little bit by making scientists more productive.
But AlphaFold 3, yeah.
That's
But Sam,
that will be a triumph.
Those are not these these models are trained and built differently than the language models. I mean, obviously there's a lot that's similar, but there's a lot, there's kind of a ground up architecture to a lot of these models that are being applied to these specific problem sets, these specific applications, like chemistry interaction modeling, for example.
You'll need some of that for sure. But the thing that I think we're missing across the board for many of these things we've been talking about is models that can do reasoning. And once you have reasoning, you can connect it to chemistry simulators or whatever
I guess
else.
That's the important question I wanted to kind of talk about today, was this idea of networks of models. People talk a lot about agents as if there's kind of this linear set of call functions that happen. But one of the things that arises in biology is networks of systems that have cross interactions, that the aggregation of the system, the aggregation of the network produces an output rather than one thing calling another, that thing calling another. Do we see like an emergence in this architecture of either specialized models or network models that work together to address bigger problem sets, use reasoning? There's computational models that do things like chemistry or arithmetic, and there's other models that do, rather than one model to rule them all that's purely generalized.
I don't know. I don't know how much reasoning is going to turn out to be a super generalizable thing. I suspect it will, but that's more just like an intuition and a hope, and it would be nice if it worked out that way. I don't know if that's like...
But let's walk through the protein modeling example. There's a bunch of training data, images of proteins, and then sequence data, and they build a model, predictive model, and they have a set of processes and steps for doing that. Do you envision that there's this artificial general intelligence or this great reasoning model that then figures out how to build that submodel, that figures out how to solve that problem by acquiring the necessary data and then resolving it to a solution?
There's so many ways where that could go. Like maybe it trains a literal model for it, or maybe it just like knows the one big model, what it can like go pick what other training data it needs and ask a question and then update on that.
I guess the real question is, are all these startups going to die? Because so many startups are working in that modality, which is go get special data and then train a new model on that special data from the ground up. And then it only does that one sort of thing, and it works really well at that one thing, and it works better than anything else at that one thing.
There's like a version of this I think you can like already see. When you were talking about like biology and these complicated networks of systems, the reason I was smiling is I got super sick recently. And I'm mostly better now, but it was just like body like got beat up like one system at a time. Fought, like you can really tell like, okay, it's this cascading thing. And that reminded me of you like talking about like biology is just these like, you have no idea how much these systems interact with each other until things start going wrong. And that was sort of like interesting to see. But I was using ChatGPT to try to like figure out like what was happening, whatever, and would say, well, I'm unsure of this one thing, and then I just like posted a paper on it without even reading the paper, like in the context, and it says, oh, that was the thing I was unsure of. Like now I think this instead. So there's like that was like a small version of what you're talking about, where you can say this I don't know this thing, and you can put more information. You don't retrain the model; you're just adding it to the context here, and now you're getting a.
So these models that are predicting protein structure, like, let's say, right, this is the whole basis, and now other molecules at AlphaFold 3. Is it basically a world where the best generalized model goes in and gets that training data and then figures out on its own? And maybe you could use an example for us. Can you tell us about Sora, your video model that generates amazing moving images, moving video, and what's different about the architecture there, whatever you're willing to share on how that is different?
Yeah. So on the general thing first, you clearly will need specialized simulators, connectors, pieces of data, whatever. But my intuition, and again, I don't have this like backed up with science, my intuition would be if we can figure out the core of generalized reasoning, connecting that to new problem domains, in the same way that humans are generalized reasoners would, I think, be doable.
It's like a faster unlock than
I think so. But yeah, Sora like does not start with a language model. That's a model that is like customized to do video, and so like we're clearly not at that world yet.
Right. So just as an example, for you guys to build a good video model, you built it from scratch using, I'm assuming, some different architecture and different data. But in the future, the generalized reasoning system, the AGI, whatever system, theoretically could render that by figuring out how to do it.
Yeah, I mean, one example of this is like, okay, as far as I know, all the best text models in the world are still autoregressive models, and the best image and video models are diffusion models. And that's like sort of strange in some sense.